Hello and welcome to our third grade math review. We are on day 11, and as always we are looking at the 2017 STAR test. Today we're going to start with some perimeter problems and then get into a time problem. So we need to remember that the perimeter, and we see that down here, means all the way around an object, and typically you're going to see it on a square or a rectangle, even triangle. But now we've got this strange object that is kind of broken up into chunks. We've got two congruent pentagons, and then we've got a square. Now the key here is this term congruent. So congruent it's a term that we use in geometry that means the same size and the same shape. Because look at what we're asked to do. We're asked to find the perimeter in inches. There's no A, B, C, or D's. We're just going to have to find the answer on our own. This is what they call a griddable response. And we're missing some numbers. We don't have the numbers here and here, which it's a square. So if we wanted to, we could put 30 inches here, but we really don't need that because we're not going to measure the inside. We're measuring the outside. But this congruent lets me know that if this little chunk of the pentagon is 12 inches, then this is going to be 12 inches. And if this appears 12 inches, it's like a mirror. Imagine you got a line of symmetry going right down the middle. It's going to be the exact same on both sides. So we could put these in from the right side. We can put them over here on the left side. And that's the only trick to this problem. That we're going to have to add a whole lot of numbers. And since there's no A, B, C, or D, we're going to have to make sure that we do it correctly. So I'm going to grab these 22s. I'm going to circle these. I'm just going to put them over here. I want to make sure I get all my 22s. Then I've got 1, 2, 3, 4 12s. And then I've got two 30s. I've got to add all of this up. So I'm going to do it all in one big chunk. I'm also going to add in smaller chunks separately, and we'll use that as our double check to make sure we got the right answer. So we've got 2, 4, 6, 8, 10, 12, 14, 16. So it looks like I've got 16. And I'm going to add my 2's first. 2, 4, 6, 8. I'm going to add this and this to make 10, 11, 12, 13, 16, 19. It looks like I've got 196 inches. But like I said, I'm going to kind of add in chunks. I know 22 and 22 and 22 and 22. That makes 88. I know 12, 12, 12, and 12 makes 48, 30, and 30 makes 60. So let's add that up in chunks to see if I get the same answer. So that's going to be 9, that's 13, 1, 9. Okay, so it looks like we have our answer as 196 inches. So the second problem we're dealing with is also perimeter, but it might not look like a perimeter simply because you are not going to get a picture to look at. All you're going to get is a sentence. A triangle has a perimeter of 18 units. Each side of the triangle is the same length. What is the length of one side? So when we say each side of this triangle is the same length, they don't give us the term, but that is an equilateral triangle. So I'm going to try to draw an equilateral triangle for you. Might not be perfect, but it's going to look something like this. And I'm just going to put these little L's right here, because it says that there are 3 lengths and they're each the exact same. So L plus L plus L, and if you take all those 3 side lengths, put them together, you're going to get 18. We don't have a unit, so they're just going to use the term unit. We can also say 3L. If I put all those up, I've got 3 L's equal 18. And so what I need to figure out is what is 1L? What is the length of one side? Well, if I know how to skip count by 3's, I can see how many 3's it takes me to get there. 3, 6, 9, 12, 16. Nope, that's going to be 15. And 18. All right, so it took me 1, 2, 3, 4, 5, 6. So possibly L equals 6. Let me see if I skip count by 6s. 6, 12, 18. Yep. 6 times 3, or 6 plus 6 plus 6, that's going to equal 18. So my answer is going to be 6. Another way to solve this would be, what happens if we just plug some of these numbers in? If we said 3 plus 3 plus 3, because I know there's 3 sides to a triangle, that would equal 9. So that's why that's wrong. 19, I guess they just took the 18 and added it to 1. But 19 plus 19 is going to be 38. Plus another 19 is going to be 57. This, I know how they got. 54. 18 times 3 is 54. So the incorrect method that's used here is going to be multiply 3 times 18. Actually, what we ended up doing is taking our 18, dividing it by 3. That's how we got our 6. So same numbers, incorrect operation. So that's a pretty simple one. Answer is G. Our final problem is number 18, and this is starting to look at time intervals, not necessarily elapsed time. That's what happens in 4th grade, where you just have in 3rd grade, we just have a start time. So we have a start time of 9 a.m., and we want to see what the end time is going to be. They're going to tell us how long something lasts. So at 9 o'clock here, we see the short hand, that's the hour hand, it's pointing right at the 9. When the longer hand, the minute hand, when that's pointing at the 12, that means it's at the top of the hour. So we'll call that o'clock, 9 o'clock. Deborah and Shelley started racing at 9 o'clock. Deborah finished in 45 minutes. We have to first figure out, when did Deborah finish? So Deborah finished, every time we move one of these big numbers, these are sets of 5. So we'll say that's 9 o'clock, that's 9:05, 10, 15, 20, 25, 30. It's always easy to remember 30 minutes. It's half an hour because that's at the very bottom of the clock here. 35, 40, 45. So Deborah finished in 45 minutes. So Deborah finished racing at 9:45. But look at what the question is asking. Shelley finished 20 minutes after Deborah. So now we need to add another 20 minutes. Well, first, let's see if we can draw a clock that would match Deborah here. So when we're drawing a clock, typically I'll just draw 12 and 6. I'll draw 3 and 9. I know where those 4 numbers are. And then I'm just going to put my 1 and my 2, my 4, and my 5 in the best spot that I can. And so when we're looking at 9:45, I know that my long hand, that's my minute hand, is going to be at the 45, because that's where I stopped right here. But the hour hand is going to be almost to the 10. It's going to be a little bit shorter, but it's almost to the 10 o'clock. And so that's what 9:45 looks like. And I need to go another 20 minutes to get Shelley. So let's start here and let's go another 20 minutes, skip counting by 5. 5, 10, 15, 20. So I'm going to end up right there at the 05. But you notice how I went past the hour? So now, rather than 9:05, my answer is going to be 10:05, because I went 45 minutes for Deborah and then another 20 minutes for Shelley. That's 45 and 20, that's 65 minutes. An hour is only 60 minutes, so that's a little bit over an hour. So we need to see which one of these looks like 10:05, and it's actually going to be this right here. So we look at this, we got this 10 right here. That's going to be our hour hand, because that's the short one. And here is our minute hand. That's the long one. That's the 10:05. So our answer is going to be F. Now, here are some interesting incorrect answers. So you see this 20 minutes right here? If you started at 9 o'clock and then just did 5, 10, 15, 20, that's where you would get. So that's where G is coming from. They skipped the 45 and they just did the 20. This 9:05, I bet you I know what they did. They did the 45, they did the 5, 10, 15, 20, 25, 30, 35, 40, 45 for Deborah, and then they did the other 20 for Shelley, So they did 5, 10, 15, 20, but they just didn't switch the hour up. Once you go back around 12, the hour is switched. And then I'm not sure where that 10 o'clock comes from. Maybe they just got really close to this 10:05. But our answer is F, and that is it. Thank you guys so much for joining me on this third grade math review.